Hello there, and welcome to Building a Planet-Friendly Web, a talk for the Sustainable UX Conference. This is a pre-recorded talk, so I won't be offended if you play me at double speed or pause me to chat in Slack. If you're watching this on the conference, I may be in Slack myself, so say hello if so. Okay, so where was I? Yes, I'm Chris Adams, pleased to meet you. I've been working with the web for the last 15 years in various jobs, but these days I've settled on environmentally focused web generalist to kind of describe what I do really. I've worked as a designer, a system administrator, a product manager, a UX consultant, a user researcher, and yes, even a developer on various environmentally funded projects and startups. My aim today is to help provide some context for how what we do fits into the wider picture of, well, basically climate change in the world, and share a mental model for thinking about building digital products with this in mind. So I'll be mentioning carbon dioxide a few times today, so I'm going to start with a super quick reminder on the greenhouse effect. Here's more or less how it works. Sunlight hits Earth. When energy from the sun hits Earth, some of it ends up warming the Earth, and some bounces back off the planet into space. What's special about Earth, though, is that it has large enough quantities of certain gases within the atmosphere, primarily CO2, to bounce some of the energy back into the Earth again. This bounced energy warms up the planet, so we refer to these gases as greenhouse gases and the phenomenon as the greenhouse effect. So, this greenhouse effect has been very useful for us. It's made life possible in the first place. Over the last 100 years or so, largely as a result of human activity, we've ended up with greater levels of greenhouse gases, and in particular CO2 in the atmosphere. So more CO2 results in a more powerful greenhouse effect, resulting in more energy in the system and raised temperatures across the planet, and more extreme weather events and so on. So to recap, the greenhouse effect in small amounts has been good, but too much of it is very, very bad. Luckily, we realised this a while ago, and in 2015, as an international community, we realised that we needed to limit further warming to less than 2 degrees Celsius. And we've made some progress. For 3 of the last 4 years, our economy has grown, but our emissions have stayed flat. And lots of commentators got excited about this decoupling of prosperity from carbon emissions. That said, though, before we start feeling too proud of ourselves, we do need a sense of perspective. Because it's taken this long to reach the turning point as a civilization, we need to reduce our emissions much more aggressively than a few years ago. The blue line on this graph here shows what we needed to do in, say, 1995, showing a kind of gentle reduction of emissions. But you can see the red line shows how much more we need to get it together now. And when it comes to climate change, winning too slowly is the same as losing, folks. So, what part do we play as technology? This deck, citing a report from the Climate Group's Smart 2020 report, shows IT at around 2% of planetary CO2 emissions in 2007. That's roughly the same as aviation. In 3 years' time, as an industry, we're predicted to be responsible for twice the emissions of aviation. So while we might not have direct control over deforestation or things like that, we do have rather more control over how we might use data centers and infrastructure for shipping our digital products to our users. So if this talk is going to be about tracking and reducing emissions, maybe it's worth looking at how to track emissions in other industries. The most common standard used is the GHG corporate standard. It's loosely based on accounting principles, and the general idea is that you can measure the CO2 emissions of any organization by putting them into kind of 3 buckets known as scopes. Now, I'm English, so I'm going to use tea as the metaphor to help explain these scopes. Let's say I wanted a cup of tea and I had a gas stove. I might burn some natural gas, a fossil fuel, to heat up water to make tea. Now, any CO2 emitted by burning fossil fuels would be my Scope 1 emissions. This scope is aimed at more industrial process than making a cuppa, but hopefully you get the idea of directly emitting CO2 from burning fossil fuels here. Now, Scope 2 emissions represent CO2 emitted on my behalf, so from generating electricity that I use. So, if I was using an electric kettle to heat up my water for my cup of tea, then I would be generating Scope 2 emissions instead. Now, Scope 3 is the final everything else category, and usually represents the rest of the supply chain an organization depends on. So if I bought a cup of tea from some local cafe, you might think of all the emissions associated with making it possible for me to walk in there and have a hot beverage. So from growing the tea to having hot water available, these would be my Scope 3 emissions. Now, if the cafe has suppliers, we need to take into account that too. And if they have suppliers, we need to take those into account too to calculate Scope 3 accurately, and so on. So calculating all these emissions is hard, but this idea of starting with direct control over sources of emissions, then moving to more indirect control over emissions in the supply chain is an idea that's useful to us and worth borrowing if we want to have a mental model for how we think about emissions on the web. And here's what I'd like to share with you today, a mental model to help think about where we might change how we build the web and the disciplines we might borrow from if we wanted to build a web that didn't have the unfortunate side effect of trashing the planet. So you can think of your packets as representing emissions generated from sending data. You can think of your platform as representing emissions from servers you're responsible for. And your process represents decisions you have made about how your organization works that bake in emissions and commit you to making certain amounts of emissions in how you work. So let's start with your packets, because that's probably where you would start, and that's also where you'd start if you were to kind of do this tomorrow. It's the data you send across the internet to your users. Now, when a request leaves your service, you don't have much control over how it routes through the web to reach a user. This is a feature of the internet and is usually a good thing. However, sending data takes energy, and you don't have control over where it goes. So how green the infrastructure that makes up the internet affects how much CO2 is emitted sending this data. Now, this map shows how green the electricity is around Europe based on the kind of power used to generate that electricity. So this is really cool, this map. It's an open source project and I really, really like it. So you can see that France is green and full of nukes, and that's why it's green. Now, Scandinavian states, they're green because they have loads of hills and loads of mountains and therefore lots and lots of hydropower. Now, Germany, in the middle, that's brown because Germany is kind of known as the land of solar and coal. Now, if you look at Poland and Estonia, they're really, really, really dark. So that's because they have lots and lots of coal. So the energy used that generated over there is very, very, very CO2 intensive. And that's kind of high carbon kilowatt hours, as it were. Now, also, because different kinds of network use different amounts of energy to move the same amount of data, we can end up with differing emissions here as well. For example, the relatively recent switch to 4G for wireless connectivity has meant that while we get data faster, it's also much more energy intensive than it was before. This means our CO2 emissions increase here as a greater amount of our traffic moves to mobile. Now, not only do we see more traffic of mobile in relative terms compared to, say, fixed lines, we also see more traffic in absolute terms, i.e. we tend to use wireless connectivity more often, and in places where we didn't use the internet before. So we can't directly control where data goes, nor control how intensive the connection used to download the data is. And we know that data is being used more often now, but we can at least control how much data is being sent when it is requested, right? Well, yes, but the trends aren't really going in the right direction. As you can see, we have an obesity crisis in mean web page size here. There's a very clear direction of travel here, and ever larger pages sent over ever more energy-intensive connections more often is pretty much the opposite of what we want from a CO2 emissions perspective. However, like one technique the web performance community has used to help fight this bloat has been the use of performance budgets in designs. While the goal here is a better user experience and a fast-loading site, it also turns out to be a pretty planet-friendly choice too, as it reduces the amount of data sent and therefore energy used, and therefore CO2 being chucked into the atmosphere. So, shout out to the WPO crew, nice one. Following on from this, an effective approach to tame page sizes has been to automate these kinds of page budgets by running checks every single time a page is updated or a site is deployed. Now, if we care about our users' experience of the products we use and we create, and if we care about the emissions that result from sending bloated pages, there are tools and practices we can draw upon to do a better job of reining in page size like this. Now, at the bottom of this slide here, these are some tools I've used and I'd recommend for using as well. So SpeedCurve and Calibre Up are both hosted tools. SiteSpeed and Google Lighthouse are open source tools that you can incorporate into any kind of tool chain if you work with developers. So we've established that sending data uses energy, and the amount of data we send per use is one of the biggest levers we have, and that we can also see this data as well. So how might we think about limiting how much data we send? Well, one way of thinking about this is thinking in terms of how much we need to send to the client in the first place when they visit a website of ours through a phone or through a browser. If most of the photos on a page aren't visible, when you visit a page, do you really need to send them? Likewise, if I know files will be used, can I send them in a more efficient way? If I've already sent that photo, do I need to send it again? Can I just take it from a cache? Can I compress things? Now, there's a veritable word salad of buzzwords that you can look up now if you're interested, but I don't really have time to run through all of this right now. And the main thing to remember is that taking these measures usually results in a better user experience, as pages end up loading faster and often leaving you with a better working site. Now, if you care about this, while we might think of this as planet-friendly to be reducing the amount of unnecessary cruft we send to our users, we're likely to have more luck selling it as a wallet-friendly intervention to our bosses in terms of letting people give us money more quickly. In many cases, they're the same thing. And the best book I found for selling this idea is this one here by Tammy Evert. So Time is Money, Business Value of Web Performance. It takes about 3 hours to read. It's really, really worth it. I'm not paid by them, I just really like the book. Now, when it comes to implementing some changes, this is the one link I'd share with you for this part. It's by far the most useful resource I've found so far, and my hope is that by linking to this, I don't clog this talk with loads and loads of out-of-date web performance advice. Thing is, and it's easy to get caught up with this mania for web performance optimization, but it's useful to get a sense of perspective. If we're talking about the web, we can change our own sites, but it may also be more effective to lobby for wider changes, like having more of the networks we rely on using renewable energy. So here's an example. Sandvine is a networking company, and they regularly produce reports like the Global Internet Phenomena series on the kinds of traffic they see flowing across their networks. Now, it's worth looking at this because it shows that in the US, more than half of peak traffic essentially comes from two companies now, Amazon via Netflix and YouTube. And we can see that the web, as we might build it, is dwarfed by them. We're barely 7%. So if you're going for climate impact, optimizing the 7% of the web that we might make up might not be the best use of our efforts. So to recap, we can't directly control how CO-intensive sending data is, but we can control how much data we do send, and we have tools and practices for doing this. That said, if we want the greatest impact, it might be worth thinking about where else there might be levers available to green the web. For example, in some states in India, legislation has been passed so that rural base stations that provide internet connectivity have to run on renewable power rather than a diesel generator. So if we can change the network and then all the traffic ends up being greener, it's a much more useful. It's a win-win here, really, basically. And so that's packets. So when it comes to your platform, as in the servers you control, there are kind of two obvious levers available: who your providers are and how you provision your computing power. Now, where we don't have direct control over how the rest of the internet is powered, we do tend to have more control over the power our own servers use. And this is arguably where it's easiest to introduce renewable power. Now, a few years back, if you wanted to run your apps on green power, you'd either need to run them in Iceland, where almost everything runs on geothermal power, or you'd use a small number of providers who either weren't very reliable or had limited product offerings or were just really poorly priced. Thankfully, you're much less likely to make a trade-off between green and effective these days, which is really good news. Like this set of commitments shows just how much the industry is starting to move now. But what if you can't just use green providers for some reason? Then there are options too, and it's worth looking at Akamai as an example. So Akamai runs something like 200,000 servers in more than 126 countries, And they typically do this by leasing space in data centers where power is already paid for. So if you want to have a global content delivery network, but you also want to support renewable power, what are your options? Well, what Akamai do is interesting. They use something called a contract for difference to buy in advance energy from a renewable project on the same grid as the data center they use. So this gives this renewable project guaranteed investment to go ahead. But Akamai has already paid for the power in the data center they lease space in. So they have agreement with the renewable provider to let them sell this energy generated on the open market, which often isn't so motivated by whether energy is from renewable sources, and use this to give Akamai a credit for this. So you can think of the kind of green part as the credit here. Okay, so while the rest of the market might not care so much about where the powers come from, Akamai do. And essentially, they're paying for the right to say that they've created demand for renewables in that specific grid, speeding the transition away from fossil fuels in that region, and hopefully allowing for the renewable energy provider to expand in future. So that's the idea of a kind of contract of difference, I suppose. The other big lever that determines how much CO2 is emitted on behalf of the digital products you build and operate is how efficient you use the capacity you've paid for from your provider, especially if you're not running 100% on renewables. Now, this graph here shows the typical usage patterns of traffic across the internet in a given area over the day. So we're all asleep at the beginning, which is why you see this dark, this pitching downwards. Then we start work, and you can see the usage pick up. Then we all go home and we watch Netflix, as you can see towards the end. Now, for many of us, we're so used to paying for compute by the month if we run servers that we don't really think too much about how capacity we've reserved matches up to when our users are awake. And often we just think about making sure there's always enough headroom to meet the top end of the traffic that we'd expect. Now, if we're thinking about the environmental impact of this provision capacity that doesn't get used, then I think that's a missed opportunity. It feels a bit like leaving the office lights on at work when you go home. I mean, this quote here really kind of hits home. 3/4 of the application time we're paying for isn't really being used. So for the longest time, because provisioning service has been slow and a hassle, it has made sense just to leave the lights on in this case, because the cost of managing this outweighs the savings you might actually make. But as we've started to use services more than servers, this has changed. So when we shift to using, say, a platform as a service, and we pay for someone else to run a database, we start to trade a higher unit cost of compute for greater ease of management of these resources. Now, this is good from a planet-friendly web perspective, as it makes scaling down during periods of low use to burn easier. And as a result, we burn less compute, and therefore we emit less CO2. But it also saves cash money, which is also a win. But what if you could get away with only paying for resources when you use them on a kind of per request basis? Now, this is known as kind of serverless or functions as a service, you don't really pay for any reserve capacity in the same way at all. I think this is really, really, really interesting. So instead of paying per month, or manually scaling how many servers you're using based on how much traffic you're expecting, you pay per request. So you pay per 100 milliseconds you spend serving a request, and you pay for the RAM you might use to serve that request. So if you can improve code to serve the same page twice as fast, then you've just halved the cost of that of your server bill, basically. Similarly, if you can serve the same request in half the memory footprint, you've halved it again. Because less CPU burned means less energy used, we end up with less CO2 released, which also costs less money. The incentives are aligned. And I think this is this piece here by, I'm going to pronounce it wrong, Gokul Ashik really, really explains why it's so interesting. And I'd really recommend looking into this if this is something which catches your eye. So you might be wondering why this talk is feeling like a talk about optimization rather than the environment. This is what I mean by there being a lot of overlap between things that reduce how much CO2 we emit into the atmosphere and good engineering practices. Google and Amazon don't necessarily care about saving energy because they're warm, fuzzy companies. They do it because it's good business sense, and they work at a scale where the incentives to save energy are great enough to justify sophisticated techniques that you wouldn't see in your typical broom closet data center. In the example above, Google deployed an AI to work out the most efficient way to save electricity in their data centers, which reduced the CO2 emitted, but also saved a huge amount of money. So when it comes to, just have a quick recap, when it comes to server view control, you can think of two things to bear in mind: who your providers are, as in where your power is coming from, and how you provision your computing power. So the final part is about your process. Decisions made about your business that bake in emissions. Now this is a long talk already, and the subjects of commutes and green offices are ones that have been covered before in lots and lots of detail. So I'll focus on getting feedback and getting paid, as they're the most kind of relevant for the web, really. Now, when it comes to building for the web, how easy we make it to learn from our users by speaking to them is a kind of deliberate choice now. So here's an example. I'm building this content as a guide. And for every Friday for the next month, I'm going to be setting aside time to speak to people who watch this video and to find out why they watched it. And if what you can do, if this is you and you're looking at this, you can book a 30-minute hangout call with me right now at this link right there. It will show up in my calendar, and then we can talk. And I'm hoping this will save me a bunch of travel, and I'll learn loads in the process. But I hope it also shows you how far you can go in bringing down the barrier for user research and actually speaking to users or interested people now. Now, getting feedback and making it easy to learn from users is important, as it helps you spot opportunities you might not see if you're used to doing things the way you've done before. An example might be in publications. We might build these beautiful, fast sites applying all these principles we've been speaking about in this talk. But if we rely on the same business models that ends up clogging up our sites with ads, we risk not only destroying our readers' user experience, but as we now know, there's an environmental cost associated as well. So the yellow lines here represent the amount of advertising downloaded versus the content of the news content on these sites here. And based on that, you can quite easily see how someone might make an environmental argument for using ad blockers just to kind of cut down on the dreck that they see. But if you're committed to a specific business model based around advertising, and your users start using something like ad blockers, then you may end up with an arms race with your users, which rarely works out well for anyone. But it needn't be this way, if we can understand what our users are really after. I really like pointing to The Economist as an example of a publication that knows its readers and has tailored how users experience their content accordingly. For example, one thing they deliberately do not do is add links to other sites in their copy. This isn't so much about withholding traffic as keeping the site finishable, something very few other news publications do. And this quote really stood out for me when I heard Tom Standage talking about this. He basically says that the thing The Economist sells is this sense of feeling informed, not necessarily the content. And if you try out the Economist app, you can really see this. You pay directly for it, and you essentially pay to be able to read it in 5 minutes every single day and feel like you know what's what. But it's not just The Economist. After a long, painful process, publications like The Guardian are now at the point where more of their revenue comes from users rather than advertising. And you can see in the copy here where they're asking people to essentially become members rather than subscribers. Now, The Guardian isn't really selling articles per se, so much as selling the fact that being a member allows the kind of journalism that The Guardian does and make that possible. And that's a subtle but important difference. And so that's it. It's a few new ways of thinking about the web, and hopefully a mental model that helps you think through where you might make an intervention in your own professional practice. If this interested you, I'm looking for people to help me turn the content here into a freely available guide and flesh out some of it in a bit more detail. If this sounds like you, I'd really love to hear from you, and here's how to get in touch. Now finally, these are the last few comments, and that's me. Thanks everyone.